Yeah. Hello, everyone. This is a GLQL sync, October 10th. And yeah, let's discuss the biggest thing that I wanted to discuss today was what we do next with the compiler and the API for the GLQL. Do we move it in Rust? Do we don't? Like, do we move it from the just being a GraphQL wrapper to its own API and stuff like this? So, Himanshu, you have the most context here.
Yeah, so talking about moving it to the backend, what does it involve? So right now we have a compiler that is written in Haskell, but it is compiled to WebAssembly. And we would like to move it to the backend. And we also have a transformer component, which basically takes the response of a GraphQL query and adds new columns or fields to it. That should also move to the backend. So essentially what I'm proposing is we have a GraphQL call for GLQL, which takes a query and gives us the data, and everything else is behind the scenes. The question is now whether we want to rewrite in Rust or keep it in Haskell. I included some benefits for moving it to the backend. It's more future-proof and scalable. Any performance concerns of expensive queries we can solve by caching, which we cannot do with front-end approach. And we can easily adapt to more targets like Elasticsearch or Cube, which are on the backend as well. Or maybe we can have a integration with Postgres as well, which isn't recommended, but still a possibility. And it can be integrated with existing Banzai pipeline so that when you write a GLQL query in a comment, the email that gets sent out to people includes actual results, not the query. And yeah, Dimitri, you have a point.
Yeah, so we already support Rust. We can ship Rust and use it on the backend, but I'm pretty sure that's not the case for Haskell. So I would say that's probably the most important point to use Rust.
Yeah, I have it
support it
mentioned.
in the Markdown compiler as well. Ship it in Rust.
Yeah, I have Rust mentioned in the section below why we choose Rust and why not keeping it in Haskell. Anyways, my next point is about when we should be doing it. I think sooner is better. Ideally, we should go before beta. As we keep on adding more features to the compiler, it becomes harder to rewrite it in Rust because it's just more work. So I think we are mature enough with the feature parity for feature availability for experimental version. We are not really going to add any more features in experimental. So I think this is the right point to transition. If people agree, then yeah, we can do it before we transition to beta. And just to add more things, our current approach doesn't allow us to add or parenthesis support. And we cannot add sorting beyond what is supported by GraphQL, and caching and snapshots is not possible. And my next point is about why not keep it in Haskell. And Rust is great for embeddability. It is very performance strongly typed and has overlap with Haskell for the most part. It also allows you to write imperative code. In the past, we have tried to include Haskell into our pipeline, but we haven't been successful. But it's been a long time since then, and maybe things have changed now. But it still would be quite a bit of work. We also have Rust experience within our team. I heard that Dimitri, you are also very well familiar with Rust, and Brett already has been working with Rust for the Markdown parser.
So I have less experience than I would like. I would say that.
Yeah, but it's still better than mine. I have like no experience, but I still have to learn, and I would be happy to learn it. Go, on the other hand, is for highly scalable applications. I don't think we want scalability here. We want it to be highly embeddable, to be used, to be platform independent and be embedded mostly in the GitLab application. So yeah, I think that is all.
John, you can voice your comments and I'll just type.
Yeah, because it'll take me a while to write them. There are a couple of things. I also agree with most of the points for moving to Rust. There are a couple of reasons to keep it in Haskell as well. I think into beta. Haskell isn't probably a long-term solution, but one of the main benefits of writing it in Haskell was during the period of like rapid change, it's very cheap and very safe to make changes in Haskell. It's very predictable. And in the initial stages, I know it feels like we're going through with development very quickly, but in reality, probably it's still there's a high rate of change currently still, and things will settle down. And I think when you've made a lot of the design decisions, you've given it to customers, validated the idea at that point, there's a stronger argument, in my opinion, for a rewrite in a more sustainable language. Um, so that's kind of the way I see it is like I'm more coming from the side of like we don't even know if it's valuable yet. We have reason to believe it is just from the adoption, I think, internally, but until we get to customers, like they might even come in with a response that we didn't expect at all, especially since our customers are like the target persona is kind of non-technical, right? Like it's the it's basically the product manager who's prepared to go that little bit further um to write a little sort of almost pseudocode to do a lot more than they're usually capable of. I looked at the implementation issue for Haskell before. Yeah, it is 9 years old in fairness. Now, Haskell is the whole build system has come a very, very long way in that time. Back then you didn't have Stack or anything, you only had Cabal. And even we use GitLab's pipelines to build GLQL, and we use the new Docker within Docker thing um, to basically build it to provide like a pre-built build environment that builds it really quickly. So yeah, I mean, like, don't get me wrong, these are well thought out arguments, Himanshu, and it's your decision as a team. I just think that I just want to make sure that the reasons on the other side are also represented. The It being in Haskell basically so far has allowed a very small team of people to make what would be considered like quite a lot of changes in a more mature product very quickly. Yeah, that's pretty much it.
Just want to mention something quickly. If we want to move GraphQL to the backend, I think it will be either really, really hard with Haskell or even impossible, if not impossible. But with Rust, it's extremely easy.
Yeah, but the nature of the compiler was that you wouldn't need to stick to one data source. You can use almost any interface, and if we were moving it to the back end, in fact, I wouldn't even think about moving it to the back end. I would think about just implementing a back end. The point of the compiler was that it could be used in almost any way. It compiles through the foreign function interface provides functions to any other library or language. So you could write a C wrapper, a Ruby wrapper, it doesn't matter. Yes, it will give you back GraphQL, but that's the other design point about the compiler was that it's very cheap to write new code generators. 90% of the work is done in the rest of the compiler, and the code generator just translates the final optimized syntax tree into something else, and that something else could be instructions to a Ruby finder. And I think that's something we should maybe look into. Instead of generating GraphQL, generate instructions for the Ruby finders, write a Ruby gem wrapper or like Ruby wrapper for the foreign function interface, and use it with our finders. That way we get the same benefits, I believe, as the GraphQL API. We get our permissions checks, our security, all that.
Yeah, I wouldn't want to see us try to do GraphQL calls in the compiler. That doesn't quite make sense to me. You know, that should generate either the GraphQL language or some intermediate component that then at the Ruby layer we go, oh yeah, we can make that in GraphQL real easy, or certainly use our own caching and direct GraphQL finder calls.
My point was more about if we want to call this compiler from the monolith, we kind of have to use Rust. I'm pretty sure we can't use FFI because it would mean that we would need to add Haskell to our stack. And I think it would be really, really hard and complicated. But we already have Rust, which means that we can just ship a gem wrapper with Rust to GitLab.com without any changes, to our self-managed customers without any changes. So it's a streamlined way to ship this to all the customers. Whereas with Haskell, we would need to do a lot of distribution work or create a completely new service.
I don't think so. I think we can compile it to I think it's a .h library, or compile it down to a library, bundle that in a gem, the same way like Nokogiri does. Wrap it in a Ruby gem or library, and then you would just install the library. I think that's how it would work.
I think we support so many different architectures that we cannot realistically expect to compile it for all the architectures. So I think that's how we've done it for all other gems. We actually compile it during the build phase.
Well, it depends on the distribution, but that is correct. And in some of the images we support, we do have to compile it directly when we build the image and build the distribution, even for Rust. But John, are you actually, so you're saying in beta you actually want to move this in Haskell down to the back end, or you want to put it in beta with it sitting where it is, and then move to Rust? Are you wanting to stick with Haskell?
For a beta feature, yeah, I would lean towards. I think what we have is getting pretty close to good enough to give a feature to the customer that would validate the initial form of the language and whether it has any utility.
But keep that on the front end for now, for the beta.
Just the way it is, yeah.
Yeah.
That would be my vote, but it's only one vote. Like you're the team who has to maintain it. It's not my project.
I mean, that makes a lot of sense to me, to get feedback on it while the team works on actually moving it to Rust, which would take at least 2 to 3 milestones, I would guess, to get, parity, and to do it right.
Yeah, I don't know much about Rust. It may have the same benefits that Haskell does. I know with the pattern matching in Haskell, you just get this kind of very secure, that's not the right word. You get this like very safe development experience where like the compiler catches pretty much everything. No, the compiler that compiles GLQL catches almost everything. When you make mistakes or you make design changes that don't work, maybe you get that with Rust as well. I don't know, but
I'm pretty sure. Yeah.
Yeah. Rust is definitely very safe and catches a lot of stuff. Well, I think my one worry is the little bit I've looked at Haskell, and I don't know how much you use monads. they're a little. I don't think they translate directly to Rust, so I think that might, and I could be incredibly wrong about that, but would take a little work, I think.
Maybe
I
you
may
can
be
use,
I may be overestimating the effort on this.
maybe you can use some kind of FP library in Rust to make the transition simpler.
Possibly, yeah.
Or just use it as a design reference implementation and copy just the design, but not the code over. Like don't do, a like for like rewrite, but maybe the decisions that were made it's like basically I think it's a 4-phase compiler where you've the parser, the optimizer, and then there's like several parts of the optimizer, syntax tree builder. You're just going to do that same thing. Yeah, like there have to be some use of monads in there just because of the the purely functional nature of the language versus the like unpredictable user input, right? You have to have a wall at some point where you say everything behind the wall is purely functional. But yeah, like it doesn't have to be a complete rewrite. It can just be a like for like kind of like the reference implementation works this way, the Rust, and that's how you test if your Rust development rebuild is going correct.
Yeah, that makes sense.
Maybe another semi-related topic. So the global search team might be responsible for the embedding abstraction layer. And we've been thinking maybe we can use a similar compiler for search queries. So I think there might be some overlap between these projects.
What is this project with the embedding?
So right now we're trying to choose the database for storing embeddings. And the plan is to create an abstraction layer on top of that. And I think we will need some kind of query language for that, because this one query needs to be supported by multiple different backends. I think there might be really nice overlap between GraphQL compiler and search query compiler that we have in mind. Just wanted to share that kind of, it's quite early, but I think it might be important eventually.
So far it sounds like nobody is actually objecting to move to the Rust. The thing that we still need to figure out is what do we want to release for beta? Do we want to just do a few final touches and release what we currently have? Use the Haskell version for this? Or do we, if we still want to do significant changes, do we want to rewrite it in Rust now? And I think all these discussions about moving it to the backend and actually having a separate API, like using finders and all that, we can postpone a little bit and discuss it once we actually have the Rust implementation and have some experience with it.
I have a crazy untested, unproved idea. What if we maybe compile Haskell to WebAssembly and use some library in Rust to use the compiled WebAssembly? Maybe that weird way we can kind of ship the compiler to the backend without doing a lot of work.
Yeah, it's compiled to WebAssembly currently as a reactor. There's two types. There's a command and a reactor WebAssembly module. This is we tried command at the beginning, didn't work too well. So it's a reactor, which is basically like the same as a local library. It exposes some functions. You can use the functions then in JavaScript by wrapping it in a shim.
Maybe you
Yeah,
can
so that's there.
access that from Rust somehow. Maybe
You could, yeah, but it's still going to
temporary.
generate GraphQL.
Yeah, that makes sense.
Yeah, but we also have to actually analyze, is there any benefit of wrapping it in Rust? Do we actually gain anything more than what we already have? If we don't, then it's probably not worth it at this moment to spend that effort.
I tend to agree with you, Amanchu. I'm not sure that would be worth the time to do that rather than particularly if you say that we can't do some of the OR support without going to another language, then I wouldn't spend the time on just wrapping it. I think I would think that we would go with beta with the Haskell and then architect out a new version in Rust and what we need to do would be my vote, I think.
And then to add, I also have a few points I mentioned in the doc. We shouldn't be thinking about the compiler as its own. We have this architecture which has the compiler, a transformer, and a presenter. Right now, we have the compiler in Haskell and the transformer is in JavaScript, which is just basically one function that adds a new column. But I would like to move the compiler and the transformer, which, by the way, also includes another parser, which is very similar to the Haskell code. I would like to move everything except the presenter to Rust. I just wrote it in JavaScript so that we can quickly prototype it because it's much faster for me to write code in JavaScript. And yeah.
Does that mean that the GraphQL calls, the actual collection of the data, would have to happen in Rust?
Yeah.
See, I don't think, I think that would limit us in terms of what kind of additional data sources we want to add. I think it would be easier to add that at the Ruby layer and leverage Redis and Postgres and all that kind of stuff in terms of caching, rather than laying that requirement on another into Rust. I think I think that adds a lot of additional complexity. Now, I don't know. I don't understand the architecture well enough to know what it would mean to pull that out, or have it written as a maybe that gets written as a separate Ruby gem or something like that. But I think it makes it more complex, and authentication and all that kind of stuff in terms of leveraging what we do.
Are you proposing, Himanshu, that like putting the languages aside, currently we have the compiler, it's a WebAssembly module, and then the transformer, which is in JavaScript. Would you be saying then like we would start by iterating and maybe have the transformer in Rust and have it all compiled as a WebAssembly module and have it on the front end in the beginning, and then is that how you see this sort of iterating?
Yeah, ideally I would have put the transformer in Haskell itself. Like there should be a two-way communication. So like in the Rust module here doesn't have to make a call, the GraphQL call itself. It can delegate the responsibility to, let's say, the backend, or in this case, Rails. And then the data comes back and it's sent to the transformer. It's just another component of the whole system, and then it goes back again. So right now it's just like a one, you send a message and receive, but it would be more like a 2 messages for every request. So yeah, ideally I would have put everything in Haskell, but yeah, it's just faster in JavaScript for the demo.
What benefit does that give though, versus your JavaScript code in Ruby on the back end and the compiler in Rust? Wouldn't it be the same thing?
I don't really understand your point.
Right now you've got the GraphQL component written in JavaScript, correct? On the front end, calling down into the Haskell compiler. But to me, that's very similar to having the transformer written in Ruby on the back end with the compiler written in Rust. What I don't understand what benefit it gives us to add the complexity of pushing that into Rust and having it call back out to, the monolith.
Because the compiler is the transformer is very dependent on the code generator. because in the end, it gets passed down to the presenter, which shows the data. And the presenter doesn't care about what's being presented. It just wants a table of data. And that's why I also mentioned in the next point where I say that writing for a new target is not just writing a new code generator. You also have to write a new presenter. You have to map all the values so that the presenter is to be in a standard format so that the presenter can present them. An
Yeah,
example of
it's a great point. The compiler basically will the compiler like weirdly returns JSON, right? And you go into the JSON, parse the JSON, the output is the actual query that you want. The reason it is that way though is that like the idea was like kind of at some point in the future it would also return a schema which says like you don't like so you ask for a query, it'll give you a query and it'll give you a schema, and you don't need to care really what system you're querying because it gives you the query for the system and it gives you the schema, and the schema is like where to find the data. So you asked for a list of issues and you ask for the issue's title and you get back a query that will give you the data you need and a schema that tells you what part of the data gives you the title, right? Like that kind of thing. But we don't have any of that at the minute. What we have is like the transformer basically hard coded to, I guess, um look for the things the user wants, right? Is that right? It knows where to
mm,
go into the query, into the response.
the transformer is just basically it's not just about the schema. The schema can be used to find data in the query, but it's also about adding new columns and aggregating data. Like if you want to add a new computed field which represents a product or division of 3 different fields, for example, rice score, you should be able to potentially do that. And there was a request, I don't know if we are going to fulfill that anytime soon, but about adding arithmetic to generate new fields, like having functions in the fields. So yeah,
But-
transfer.
Sorry, can I interrupt a little bit? We only have like a couple minutes left, and I wanted to steer this back a little bit to like what decisions do we make for the next couple of weeks. Nobody's against moving into Rust. The only question, like, when do we want to do it? And I guess, do we want to release beta with it or not? For this, Himanshu, can you work with Matthew on preparing the like minimal feature set that we want for beta? See how much do we still have to do there, and then I guess we can continue the discussion. I think on like, do we use a Haskell for it or do we want to translate it to Rust? And another question, like top of your head, how much will it take to rewrite the compiler in Rust?
I think I mean, I just have to learn a bit of Rust, but I did an experiment a couple of almost a month ago, and I was able to write a smaller version of the compiler in JavaScript. So with DioChat's help, I can potentially rewrite it in Rust as well. That is also how I've been doing contributions. So maybe in about 2 milestones, I think we can do that.
Okay. Okay. I also need to drop off. You can continue discussing if you want. But yeah, please communicate, I guess, with Matthew on the feature set for beta, and we can decide when we want to move it to Rust. Cool, and I'll try not to end the meeting when I leave if you want to discuss stuff. Please continue, don't wait for me.
trying to remember what I was going to say before. It still just seems like having the compiler as its own gem that returns what the query is compiled out, and then the transformer sits on top of that, right? That I don't see the necessity of having that in Rust, and I think it complicates it if we're trying to do the GraphQL calls. And if when you add an additional data set, support for additional data set, the compiler, I don't think, would ever need to change. That would be relatively static. So, right? The actual compiling of the query into a generic form, into JSON, right, should be relatively static unless you're adding support for or something like that. But that's generally just extending the language. So then the compiler itself would be its own crate or whatever, but they can remain separate, and then the handling of that would be up a layer, either in the monolith, or I mean, I suppose it could also be in Rust or whatever. But I think it's better to separate that and leverage the monolith for rather than calling back in. It just the two-way communication, Rust calling back into Ruby. I feel like it adds an additional complexity that's not required.
I will explain why it is required. First of all, the transformer has its own parser for the fields function. So when you try to create a new computed column, like for example, by adding the labels function, or if you want to compute a field on top of existing field, or you want to aggregate or group by in the future, that all transformation happens on initial source data, which is already retrieved by from GraphQL. So,
but that's all after the compilation, correct? That's after the query has been compiled into JSON, right?
There's two compilations happening. One is of the query and one is of the fields, which is also why I have been advocating for using SQL, because then it's just one query, selects fields from the query, and then it's just that this is another rabbit hole of discussion.
But isn't, yeah, I'm sorry, go ahead.
Right now, the state is that we have basically two compilers. We have a transformer, which is also compiling, not really parsing the query to an AST, and then the AST is used to transform the data into something else.
But so I guess that's my point, though. The conversion of what the user has typed in, that language which we support, that's compiled by the Haskell component today, right? And
No.
returned as JSON, right?
No. No. It's half of it is in Haskell, half of it is in JavaScript.
But okay, but your JavaScript calls into the Haskell compiler, correct, and returns back JSON, right?
No, the Haskell compiler just returns a GraphQL query, and once you have the GraphQL query, there is a transformer in JavaScript that transforms one JSON into another JSON.
Which JSON? The GraphQL query is JSON?
The response.
The
response data. Yeah, it transforms it into
yeah, but the Haskell component doesn't actually do the GraphQL calls, correct? It's converting into GraphQL language as a AST or as a JSON or whatever. It just returns back what it thinks the GraphQL calls would be, correct? Then the transformer layer actually ends up executing those, or it adds additional components to it and then executes the GraphQL, correct?
It adds its own AST. The transformer has its own AST for the fields function.
And it doesn't call back into the Haskell component, correct?
No.
Okay. So my point is you've already got it split out. you already have the Haskell component separated out, isolated. You know,
Yeah.
we could argue back and forth whether GraphQL is the right thing to return, but at the moment it's already isolated out, and you're dealing with the GraphQL, the execution of GraphQL calls, and any additional transformations, the columns, etc., in JavaScript. And I would argue that that's the better way to do it. That the Haskell component, as it stands, would be pushed into Rust, and the JavaScript piece, which is actually executing the GraphQL calls, is pushed down into the monolith, into Ruby, or into its own separate gem. Okay, where that gem then calls out to the Rust component, similar to what we do with the Markdown parser. We've got the Markdown parser that actually does the work, and then the gem component, which does any additional transformations that the monolith calls into. So what that would mean is that you could then have different Ruby gems where it always uses the same Rust crate for compiling the common language, and at the Ruby gem level, you've got your different data sources, whether it's SQL, whether it's GraphQL, whether it's whatever, and have it separated out like that. And anyway, that's kind of how I would envision it, at least initially. And you're already there. You've already got that split. So I'm not sure. I don't see the full benefit of pushing what you have in JavaScript also into Rust.
My reason for doing it in JavaScript was because my Haskell skills are not that great.
No. I get that. But I think that still makes sense in terms of the split.
The reason, primary reason for having them together is that the transformer is also basically a compiler. It's using it's generating its own AST. Once you have that, or maybe what we can do is, if you don't want back and forth communication, you just send the query, the whole query, not just the query part, to the Rust compiler, and it gives you back the GraphQL call and the instructions on how to transform it, which is the AST from the transformer. And then the Ruby part executes the query, whether it's GraphQL or something, and then uses those instructions, the AST, to transform the query into something else. We can do that.
Okay. I think that would make sense as well. Yeah.
My point is because building a parser in Ruby is not so great.
Okay. I can't argue one way or the other about that. I mean, we do that with Nokogiri and stuff. But okay.
Yeah, I mean, we do that, but my point is that I don't want to have a language where half of the parser is in Haskell, sorry, Rust, and half of it is in Ruby. The whole queries parser should be in one language.
Okay, that makes sense. So if we can keep the query of the data, the transformation with the actual data and the calling of it in an upper level, and then the crate manage all the compilation, not putting everything together, but I think that would make sense. Yeah.
And this whole debate is only happening because we are not using SQL-like syntax. If we had like select something from query, it was so obvious that that's the query. It's not just the expression.
But that would okay. See, one part I keep thinking, and again, I haven't been involved with this. I keep thinking that the compilation of the syntax, it can be more generic than not tied to specific tables or not tied to specific entities or, you know, the way in which we put queries together, SQL, because we do a lot of optimization on that. So if you returned SQL, you know, you're still, it ties it a lot to how we end up doing optimization and caching. And I would be hesitant to put that into the. I'd like to see this compiler be more open source and open, so it could be used in a variety of cases where GLQL could be used in multiple situations that are not necessarily tied to GitLab. Seems like it'd be an interesting.
I'll be honest, the compiler is like not really much work. It's just one line. It's just one simple file. And it is very heavily coupled to issues. It's going to be there are a lot of points about adding it being easy to add new data sources, but it's the truth is that it was built for issues, and it's going to be a lot of work to add more
extend
sources.
it to other things. I mean, it makes complete sense that it would be issue focused right now, but it's going to be, I can see we're going to want to use it in a variety of places. MRs, epics, or, you know, and if search wants to use something similar, then okay.
Yeah.
Pretty cool, man.
I think we have an agreement. My point is only that the compilation stays in one language. The transformation can happen in Ruby. That's okay.
Okay. Yeah, cool. I think that makes sense.
Yeah.
All right.
Then have a good rest of your day.
Yeah, you too. Thanks.